The start of this lesson is really just doing the same process that we did previously with somewhat more difficult integrals, but basically when we skip the limit definition, I kind of showed already how we were going to do these problems. What we're going to do is integrate what's inside, then evaluate based on the limits of integration. So, when I start with 3 over x squared, I really need to see that as 3x to the negative 2. That negative 2, in the process of integration, I have to add 1 to. That's going to change it into a negative 1. I then need to divide by the new power. For a 2, there's no x's there, so just an x appears. So it's going to be plus 2x. This is going to be evaluated from 5 to 6. Cleaning it up a little, x to the negative 2 plus 1 is x to the negative 1, which goes to the bottom. So this becomes negative 3 over x plus 2x, being evaluated from 5 to 6. I now want to plug in the 6 everywhere where I see an x, so it becomes negative 3 over 6 plus 2 times 6, and subtract from that, plugging in a 5 everywhere where I see an x. So negative 3 over 5 plus 2 times 5. Definitely use your calculator at this point, but basically what I see is this is going to be 12, this is going to be negative a half, so that's going to leave me with 11.5. This is going to be 10, this is going to be negative 0.6, so that's going to leave me with 9.4. When I do this subtraction, I should get 2.1. For problem number 2, same general idea. Key distinction here, they switch from u to x, but as long as it says du, it doesn't really matter what letter they decide to use. As long as it's with respect to that same letter, we can integrate. So, u is currently to the first power. When I add 1 to that power, it becomes u to the 1 plus 1, or u to the second, and I divide by the new power. This is an understood u to the negative third. I'm going to add 1 to that. So it's going to become 4u to the negative second. I'm going to have to divide by that same new power, negative 2. When I clean this up a little, and this should all be evaluated from negative 3 to 1. When I clean this up a little, it becomes u squared over 2. This negative and this negative cancel to give me a positive. This 4 and this 2 cancel to just give me a 2 on top. So it becomes plus 2 over u squared. This is being evaluated from negative 3 to 1. So first I plug in the 1. That gives me 1 over 2 plus 2 over 1. And then I subtract from that when I plug in the negative 3. That gives me 9 over 2 plus 2 over 9. 1/2 plus 2 gives me 2.5 minus 9/2 is 4.5. 2/9 is 0.222 repeating. So that would give me 4.27 repeating. When I add these together, or I'm sorry, when I do this subtraction, you know what, I might as well have gone out a calculator. So if I do 2.5 minus 4.27, that gives me negative 1.77. If I do it as just fractions, just to check my fraction math that I was doing as I went along, 1/2 plus 2 divided by 1 minus parentheses 9/2 plus 2 divided by 9. Alright, that gave me negative 2.222. So something went wrong here. Oh, I subtracted when I was supposed to add these two. Sorry about that. So this shouldn't have been 4.27. it should have been me adding 0.22 to the already 4.5, so it should have been 4.77. That's why when I do this subtraction, I get negative 2.22. It's a good reason to always rely on your calculator and not try and showboat. When I go to number 3, here I have negative 1 to 0 of t to the 1/5 minus t to the 4/5 dt. Remember, when we integrate things, we add 1 to the current exponent, divide by the new exponent. So the current exponent is 1/5. If I add 1 to that, that would give me t to the 6/5. Remember, adding 1 is like adding 5/5. Whatever the new exponent is what I divide by. So this is being divided by 6/5. Minus, when I start with 4/5 and I add 5/5 to that, I get 9/5, which means I also divide by 9/5. This is all being evaluated from negative 1 to 0. Cleaning this up, when you divide by a fraction, you can flip and multiply. So this becomes 5t to the 6/5 divided by 6 minus 5t to the 9/5 divided by 9. First thing I plug in is 0. 0 makes both these 0. So these are all connected to t's. I don't have to worry about when I plug in 0. When I plug in a negative 1, negative 1 to the 6th power makes it a positive. 5th root also comes out as a positive. So this becomes positive 5/6. Minus, when I take something to the 9th power, it still stays negative. If I take the 5th root of something that's negative, it still stays negative. So this becomes a negative 1. Negative 1 is the result of t to the 9/5 times this negative 5 makes it a plus sign. So really, my answer is negative 5/6 plus 5/9. If I put that in my calculator, 5/6 plus 5/9, it gives me 1.38 repeating. So negative 1.38 repeating, or negative 1.389 if I had to go to 3 decimals.